Start 10 minutes after the hour. We're going to start things on time. So hi, I don't actually know, I think the live stream's up there. Everyone in the audience here, if you weren't aware, we're also live streaming this. So everybody here in the audience and everybody out at home, if you could take your phones out and instead of putting them on airplane mode, open up Twitter and find @NuclearBootcamp, that's us. We'd love to hear from you during the presentations. You think I'm kidding, but I'm not. Anyway, we're here at the closing ceremonies for the second annual Nuclear Innovation Bootcamp. My name is Kathy Shields, and I will be emceeing today. I'm really excited to get started, and I'm just going to kick us off right away with some introductory remarks from Electrical Engineering and Computer Science Professor Sujay King Lim.
All right, thank you. All right, good afternoon and welcome everyone to the College of Engineering and to the second annual Nuclear Engineering Bootcamp. I'd firstly like to start off by expressing deepest appreciation to Professor Rachel Slabo and to Kathy and the rest of the organizers, as well as to the mentors, experts, and additional volunteers who've made this event possible. Thank you very much for your hard work. So it's really nice to see so many people here who care about clean energy and a sustainable environment, and maybe nuclear science and engineering as well. Your active participation in this remarkable...
I'm not hearing anything.
Okay, that's not, okay, I can start all over.
You can keep going.
So that's I assume is Professor...
You're good now.
Okay, Professor Sachs, can you hear us now?
I can, thank you.
Fantastic. Okay, welcome. I'm Sujay Liu. I'm an engineering faculty member here and also vice provost for the of academic and space planning here. So I'm just going to set the context for your remarks in just a couple of minutes. So I think we all know that the Bay Area is renowned for its entrepreneurial culture. And so it's fitting that this boot camp was initiated here at Berkeley. How many of you actually know that Berkeley, over the last 10 years, Berkeley graduates have started the most companies of any university in the world? Did you know that? Yeah. Well, there's this other university in the Bay Area that's also known for starting a lot of companies, but it turns out that our graduates have started more. But to be fair, okay, they've raised more money on the other side of the bay, but that just shows that we're more efficient, right? Right, we can do more with less money. So today here at Berkeley, I hope you also know that we have a lot of programs that are designed to train new entrepreneurs and also to support or to incubate new startup companies. And ultimately, we are doing this because we know it's a good way to accelerate the adoption of innovations to really benefit our global society. You actually might be surprised to learn that today there are more than 50 startup companies in nuclear energy throughout North America only. And today you'll hear pitches, I think, from 5 or 6 teams in this space. So under the theme of Tomorrow, Today, each team has envisioned a new startup that solves a pressing issue in some innovative way with potentially revolutionary impact. So I hope that you're all excited as much as I am, to hear from these teams. So to set the context for their presentations, Professor Jeffrey Sachs, who is online with us via Skype, he will talk to us about the importance of clean energy for sustainable development. He is a world-renowned professor of economics, a leader in sustainable development, a senior advisor to the United Nations, a best-selling author, and a syndicated columnist. So please join me in welcoming Professor Sachs to our screen. All right. All right.
Thank you very much. I'm really delighted to be with you. Can you hear me okay?
Yes.
Afternoon. Oops. I think if you turn down the mic, that'll be better. Your microphone on the computer, possibly. Okay, let's do this. I think this will work. It's fine with me. I just turned it down on my side. So let me thank you for this boot camp, first of all, which is a fantastic idea and very important. And thank you for including me. I am an economist, and I am working on the public policy of sustainable development. I'm the special advisor to UN Secretary General Antonio Guterres on sustainable development, and that includes the fight against global warming. So in September 2015, all 193 UN member countries adopted the framework of sustainable development, and specifically 17 sustainable development goals that range from ending poverty, fighting hunger, promoting universal coverage of healthcare, to the environmental objectives. And the 13th of the 17 is to stop human-induced climate change. And there was an asterisk in adopting those goals that say we will guarantee global diplomatic support for what comes out of the negotiations that will take place in Paris back in December 2015, a few weeks after adopting this Sustainable Development Framework. And as you know, in Paris on December 12, the same 193 governments adopted the Paris Climate Agreement. And it's kind of our last chance on climate safety, because we're just in a blowout right now where, because of inaction, ever since the signing of the Framework Convention on Climate Change way back in 1992 at the Earth Summit, we're already basically at the very end of our capacity to achieve climate safety. The Earth has warmed about 1.1 degrees Celsius compared to the pre-industrial level. We have a lot of further warming already built into the Earth's systems, but we're just, with the imbalance of the ocean, still warming. So because of thermal inertia, there are still some tenths of a percent of 1 degree C that are built in to the current levels of greenhouse gas concentrations. And if we're going to achieve even a modicum of climate safety, and especially to achieve the Paris Climate Agreement, we have to radically decarbonize the world's energy system within the next 30 years. So my colleagues, the climatologists, tell me that when Earth was even slightly warmer than it is right now, maybe even just a half a degree warmer, the last time that that was true was the previous interglacial period, the Eemian period, which was 115,000 years ago. And the bad news is that during the Eemian, the sea levels were about 6 to 8 meters higher than they are today. So we're just at on the edge of already putting in motion perhaps an irreversible loss of parts of the Antarctic and Greenland ice sheets. Now, therefore, this is no joke, even though our government treats it as such right now. We are basically at the very end of our capacity to stay, in the words of the Paris Climate Agreement, well below 2 degrees C. That's the target of Paris, well below 2 degrees C, with the aim to stay below 1.5 degrees C, which is almost surely out of reach right now, except possibly with overshooting and then return. We probably could stay below 1.7 or 1.8 degrees C, all relative to the pre-industrial. But that would require living within an extremely tight carbon budget if we want to have a high likelihood of success. And as I'm sure most or all of you know well, to stay at 1.7 or 1.8 degrees C relative to pre-industrial, we have perhaps 800 billion tons of CO2 emission remaining. And we're emitting between 35 and 40 billion tons a year right now. So we have well under a quarter century remaining of a carbon budget at our current emissions rates. And that means, as every climatologist will tell us, that we have to be on a path of radical decarbonization between now and mid-century and reach something like zero by 2050, and perhaps through biological and geological storage of CO2, go negative in the second half of the 21st century. So this is a phenomenal challenge. We've never engineered a global transition of the energy system in this kind of stark way before. We have a market economy which generally has guided the energy transition since James Watt's steam engine back in 1776. And the world economy evolved mainly through market forces and, of course, government infrastructure over more than 200 years, about 250 years, as a fossil fuel-based economy. And now we have to decarbonize in a matter of 30 to 35 years. It's an unprecedented challenge. It's unprecedented because it would require the best of engineering and the best of global cooperation to achieve success, but we also have to do it in the face of relentless opposition from the coal, oil, and gas industry. And of course, in our country, we are almost a petrostate and have been for 100 years, where the power of coal, oil, and gas has been, for the last century, really perhaps the most powerful single lobby in the United States. And that lobby still owns the Republican Party. And it owns it in no small part through the handiwork of two brothers, David and Charles Koch, who between them have $100 billion invested in oil and gas, basically. Or their net worth, I should say, is through the investment in oil and gas. And they're fighting a rearguard action which is as ugly and corrupt as can be. And that's why President Trump was sent a letter by 22 congressional leaders in the week before Trump pulled out of the Paris Climate Agreement. And I emphasize all of this because it sometimes looks like the president's just a dingbat, which he is, but it's more than just the foolishness. It's actually a very powerful lobby. Now, this comes to you, and I'm absolutely delighted that you are the young cutting edge of technology on giving options. The fact is, and I really want to say this very clearly, despite the rearguard politics of this process, despite a president who would say anything and tell any lie on almost anything, by the way, we are actually on a path of decarbonization. And though the Trump administration tried to break the Paris Climate Agreement this past spring, in advance of the G20 meeting in Hamburg, Germany, they went around diplomatically trying to tell the Russians, hey, come with us, or the Saudis, come with us, the Turks, come with us. No other country broke. And so at the G20 in Hamburg, Germany in July, 19 of the 20 countries said the Paris Climate Agreement is non-negotiable, and we stick strongly with it. The United States stood out in its foolishness by itself, but even the United States will come back because almost everybody knows better. It's just the corruption that got us to the current mess, but the corruption's going to be overcome also. So that comes to you and the following challenge. And that is, how should the U.S. and other major emitting countries decarbonize the energy system? This is an analytical question that involves complex decision-making of a very complex energy system over many dimensions and a high level of uncertainty and a time horizon, as I said, of 30 to 50 years. And that kind of analytical work is underway now, thank goodness, with increasing frequency. I've been leading teams on looking at deep decarbonization pathways to mid-century for the main emitting countries of the world. And you can actually look up online, because I think they're interesting, the Deep Decarbonization Pathways Project, to look at some of these scenarios that are looking at a macro level at how the energy system can be transformed. And all of these scenarios have essentially the basic point that we need energy efficiency, we need zero carbon electricity, and we need to switch from the internal combustion engine and boilers and furnaces to electricity or electricity produced clean fuels like hydrogen. So the transformation, the deep decarbonization path, is a path of energy efficiency, zero carbon power generation, and what we call fuel switching, mainly going to electrification of vehicles and home heating and cooling, or to the use of hydrogen through hydrolysis for similar purposes, for fuel cell vehicles rather than electric battery vehicles. But all of the country pathways are similar. And I think the burning question, if I could call it that, is how to get to zero carbon power on a large, reliable scale. And as, of course, you know well, you're in the middle of it, that's a pretty fierce debate. What can be done on the basis of renewables, wind, solar, new storage ideas, pumped hydro or other kinds of reservoirs, or other kinds of storage, for instance, direct transformation of wind and solar into synthetic fuels through carbon capture and reuse? And to what extent should we be exploring a large and growing role for nuclear? And to what extent should we be exploring carbon capture and geologic storage? And there are huge proponents of all of those pathways, and they fight pretty bitterly. And generally, that means that all of these different pathways have a lot of merit. And of course, the ultimate shares of different methods of power generation, different methods of different fuel carriers will depend a lot on how technologies unfold and a lot on public policy. If you go to Germany these days and talk about nuclear energy, you know, you're absolutely just booed off the stage. They don't want to hear a word about it. If you go to China or Korea or India, of course, it's a central part of the mix, and with many, many plants under construction right now. In the United States, it's highly contested turf. And part of the problem is we've not had the young entrepreneurial crowd like you are for a long time saying, hey, there are really, really important, interesting, safe, new technologies, small modular reactors or different fuel cycles that can address the challenges of safety, proliferation risk, and so forth. And now there is a tremendous excitement about new ways of approaching nuclear power generation. So I'll come to a close here. I am a consumer of what you're doing, an urgent, eager consumer of the results of your work and deliberation. My job is to advise the United Nations and to talk about what options are, what kind of global cooperation is needed. I am convinced myself from my discussions with many, many colleagues around the world that there is an important, inevitable role of nuclear energy in the global decarbonization. I am an avid consumer of different models, pathways, economic estimates that debate which role in which places and which kinds of technologies are likely to unfold. But I believe that the next few years will play a really decisive role in these choices, partly because we're running out of time. We're going to have to take some pretty strong decisions. And part of that will be what kinds of technologies are available, what novel pathways, to what extent should nuclear serve the role of power generation, to what extent should it play a direct role and a different role, for example, through direct desalination or direct community heating or hydrogen production or other possible uses as well, of which there are many proposed pathways. And how do we create a public policy environment in which the public is well informed, in which debates are taking place on a well-informed, evidence-based, rational, and considering the range of options? I mean, maybe we've lost the White House for a few years, but the more general public would actually still like an evidence-based discussion. And therefore, the kinds of work and brainstorming that you're engaged in at the boot camp is really essential. This fall, I will be continuing to host a number of gatherings at the United Nations on deep decarbonization pathways. And I will, for one, be extraordinarily eager to hear what you have come up with in these 10 days of intensive deliberations that I understand you have underway. So thank you for letting me join you. It's a pleasure, and I really look forward to learning from you. Thanks a lot.
you so much for success.
Oops.
Oh, wait. There we go. Thank you so much. Oh, you're right. He did miss the applause because we were muted. Well, we applauded for you. Thank you so much. Applaud for him one more time, guys. Oh, I guess. All right, and before we get to the meat of the presentation today with our pitches, I would like to introduce and thank for her genius and her inspiration and her energy, Professor Rachel Slabaugh.
On. So this year was quite different from last year, but something that hasn't changed is that many people came together to make this boot camp amazing. So first, I'd like to thank all of the sponsors and supporters. We could not do this without you. We've had 5 organizers, 15 volunteers, 50 mentors, and 65 speakers donate their time and energy to the boot camp. Of those volunteers, I'd like to specifically call out some departmental staff, Alan Boland, Lydia Liu, Hannah Lorica, and Christina Castellanos, and some exceptional and tireless students, Kathy Shield, Milish Otts, Carolyn Hughes, who is watching us from Los Alamos, and James Kendrick. I'd also like to thank our co-organizers. This year, the curriculum was organized by 5 universities. So the others are Adrian Coué from UW-Madison, Sama Bilbao y Leon from VCU, Karush Shervin from MIT, and Pavel Svetkov from Texas A&M. And this year, we also had an advisory board. Todd Allen from UW-Madison and Third Way, Rita Baranwal from Gain, Gigi Wang from Sutarja Center for Entrepreneurship and Technology, and Jordi Roglins-Ribas from Argonne. And more than anything, I would like to thank 2 people who really did all of the work, basically. Sarah Harmon, who had a family emergency during the boot camp and still contributed from afar, and boot camp hero Josh Rahak, who tirelessly hauled carts of 48 air pots of coffee and washed hundreds of dishes while managing to still run calculations for the paper I'm bothering him to get out the door. So there truly are too many thank yous to say. And we value the contribution of each and every one of you. And thank you so much for contributing to this event and for taking a stand for a clean energy future. So thank you.
Okay, so now we get to start the meat of our presentation, which is the student pitches from our 6 this year student groups. Before we get started, just a little bit quick rundown of how this is going to work. The student groups are going to come and pitch in the order that you see them here on the screen. There are 5 judges here who they will be pitching to in addition to the audience in this room and online. The students will have 5 minutes, and anybody who was here last year or watched us last year knows, and they know as well, that at 5 minutes, I will walk on stage and take the microphone away from them. Last year's students didn't think I would actually do that until I chased them across the stage. So, students, you have been warned. Audience, please laugh at them if I have to take this mic away. After the pitches, the judges will have 3 to 4 minutes to ask questions of the student groups. Audience members, you should have gotten a card with your program, and you're free to write down questions on those and pass them to the edges. Milish and Josh will, or Milish and Hannah, I think, will collect those, and I will run a Q&A later in the event. If you're online, please feel free to tweet us questions if you have them, and I will do my best to get as many questions from in the room and online asked as we can. So, without any further ado, I'd like to introduce from Athena, actually I don't remember which student is from Athena because I am not on top of it today. Jonathan Yunso, come on up.
You have a clicker? All right. Works good. There we go now?
Yep.
We're good?
You're good?
Well, welcome everyone. Thank you for joining me. My name is Jay Jinso, and our team consists of Vivek Maradia, our CEO, Eureka Menankiti, our VP of Marketing, and myself, acting as the CTO. And today we're really excited to share with you what the vision of our company is. But first, we'd like to show you guys a quick clip.
In developing countries, the business of non-destructive radiography testing is growing rapidly. With this rapid expansion in business, unauthorized use of radiation sources is increasing. Let's take an example from Mark and James, who both have started their own companies offering this type of testing. Mark has decided to invest in his company by being certified as a radiation source operator, purchasing proper safety and security equipment and proper training. As a result, they have met the government's criteria to check out radioactive sources. On the other hand, James's company doesn't have the proper infrastructure. They have unqualified staff, and they lack a proper safety culture. For these reasons, James's application was denied. In order to keep business afloat, James persuades Mark to borrow the radioactive sources for the times where Mark's business is slow. Although illegal, this allows both companies to cash a profit. However, this type of activity often leads to many people being exposed to high levels of radiation, and it also sets the stage for a major national security concern. This scenario presents itself in many places around the world, and fatalities have been reported. It is with this in mind that we created Athena.
Okay. I guess it's not working. Let's go about the clicker. Accidents relating to the misuse of radioisotopes are happening all over the world. And each year, there's many reports of people getting ill because of this or actually dying. And we're trying to prevent this. But how are we going to do this? We're going to do this by designing the first ever RFID tracking and monitoring system that gets mounted directly at each radioisotope source and that can provide us with real-time location tracking 24/7. The idea here is to put our devices in each one of the samples so that whenever these samples get outside of its designated area, its designated facility, we'll know immediately and we can notify the authorities. We understand that there's three main radioisotopes that dominate the market, and that they actually come in very standardized sizes, form factors, and geometries. So it's really easy to apply a same design for a vast majority of them. So what's our strategy? Our strategy consists of three main things. The first point is designing this technology by partnering with the right team of experts and the right teams all over the world, especially to help us address some of the biggest concerns that we have right now. Secondly, we will sell the tracking and monitoring services to local government authorities. And lastly, we will work hand in hand with these authorities to facilitate the proper and correct use of these radioisotope sources. Our first market analysis, which is our target market, is India. Currently in India, there's 5,000 radioisotope sources that the country uses, and more particularly, 2,000 of these institutions actually use them throughout the year. These institutions pay an average of $1 a day per disk per source in order to keep them in their facilities. If we were to match this $1 price to put our services and our device into the samples, our company can expect a revenue of $1.8 million a year just in the Indian market alone. This is what our company project roadmap looks like. As I mentioned, the first 12 months will be a product development phase. We'll ensure that this technology can come to life, followed by 9 months of production, so we can officially start our first consignment with India 21 months from now. Looking forward, our vision is to expand to other markets where it's already proven that the same issues are happening in terms of radiation sources. Following this $1 price model that I just described, we can expect to become cash positive 30 months down the road. And right now, we're seeking an investment of $1.5 million to help us through product development and $1 million for production costs. See, next one. When it comes to competition, there really is none. There are some companies that specialize in source management solutions and GPS tracking of nuclear waste, nuclear casks, nuclear equipment, but nobody right now is targeting this particular market segment. It is with this in mind that we decided to create Athena. And we'd like to ask you to join us, not only investing, but also partner with us in our efforts toward nuclear global security. Thank you.
So that the kids at home can hear you.
Thanks, great presentation. I was wondering if you have a technique for making sure that they cannot remove the RFID tags in the facility if they were trying not to comply with the monitoring. So like clothes in a store where you can't take it off.
So we develop a technology which consists screws. So if they try to remove that screw, it will automatically send a message to the regulatory body.
Okay, so on costs, first of all, you want to charge $1 for $1, so it's 100% increase in their cost?
Yep.
So how would that affect the end user's kind of profit and
Because they are
business?
like currently they are paying $365 per source for 1 year. So like they are earning a lot from that. So they are allowed, like they are incapable to pay more $365 for the security issue, and government force them to implement more security, they have to pay.
Okay, thank you.
What's the ultimate size of the worldwide market? How big a prize are you going after ultimately?
So right now our focus was primarily India, especially because looking at all the cases that were reported, the problem is that not all the countries are favorable in reporting these accident scenarios. So finding data of actually what the need is in different countries, it's a little hard. But we did find a lot of data for India, and that's why we decided to focus on this one.
Do you have a guess?
Not at this moment.
So if you extrapolated India to the rest of the world,
So
that would be a very,
like 7,000 sources.
yeah.
So we don't,
In Africa, they have, if you combine all Africa, they have like 4,000.
So how big is the market?
so we're looking about 3-4 times what the Indian market will be, just in those 3 countries alone.
Okay.
Thank you. Thank you, guys. All right. Next up from Condor, please welcome Mitch Negus. The clicker does work.
It does. Excellent. Which, assume up is forward.
I think it might be the opposite way.
There we go. Sorry. All right. My name is Mitch Negus, and I'm thrilled to be representing the team of Condor here. All right. So, if you could tap into a $50 billion market while solving one of humanity's most daunting challenges, would you miss your chance? I certainly wouldn't, and so that's why here at Condor we're tackling the issue of used nuclear fuel. So today, used nuclear fuel is stored in dry casks like this one. They're solid concrete and are a couple times the size of your average adult, and they weigh anywhere from 80 to 200 tons. So you're not moving these things very easily. Inside of that dry cask, there's an internal canister made of metal, and that is sealed to prevent the highly radioactive nuclear waste from getting out of the cask. Now, it's estimated that there will be 100,000 metric tons of used fuel provided or produced in the United States from all of the United States' current nuclear reactors, and it's estimated that each kilogram of that nuclear waste will cost $500 to be disposed. We've done the math for you, and that's the $50 billion that we were talking about. Now, the United States government created the Nuclear Waste Fund in 1982, and the utilities have paid into that. But currently, that waste fund stands at only $22.5 billion, and if you factor in the projected maximum of that waste fund, it only gets to 32 billion. That's still almost 20 billion shy of the 50 billion that we're projecting. And so that's where Condor comes in. Condor takes two well-known, understood topics, reprocessed nuclear waste and advanced reactors, and combines them together in a single loop and on a mobile platform. This mobile platform can be brought to nuclear power plants, and the nuclear waste can be input into the cycle. Commodities such as medical isotopes can be taken out, and the remaining product from the reprocessing fed into the advanced fast reactor cycle, which is then output as a vitrified waste product, which is much easier to deal with. So, DOE, pay attention. We're talking to you. You're the ones who have been enlisted to take care of this, and so we're marketing our product at you. So, we're saying that we're better than all of the existing technologies, whether that's current disposal in a site like Yucca Mountain underground, or reprocessing. So, moving forward, on-site management, we have that covered. You don't have to move those 200-ton casks anywhere else. We're coming to you. Next, the amount of time that it takes to neutralize the waste in our combined cycle is significantly less. Here, you can see in the graph, direct disposal takes almost 10 times more years to reduce waste and neutralize as current reprocessing and advanced reactor technologies, and we're even taking it a step further in our proposed plan down to on the order of 330 years as opposed to hundreds of thousands. Now, following that a little further, you can then extrapolate and say that because our waste is less radiotoxic, in the long term, you don't necessarily need a deep geological repository like Yucca Mountain. Something that has more relaxed constraints would be more than acceptable. Also, non-proliferation concerns. Our fuel cycle research and development plan will include methods to make sure that when we separate the products, we're not allowing the weaponizable products to leave our system. They will be contained. And finally, as I mentioned earlier, we will be creating marketable products such as medical isotopes or noble metals. All right, so as you can see, we're still well out on top. All right, so how are we going to do this? The team is a series of us 5 engineers. Sasan's missing, unfortunately, but we have a background in a whole variety of engineering disciplines. We have Adria with a degree in chemical engineering, Sasan, background in electrical engineering, Shirley, nuclear engineering, but specializing in operations and maintenance, Stathis, fuel cycle and waste disposal, and myself, computational modeling and simulation. So real quick, how we're going to do this. Phase 1, the next 3 years, we're looking to demonstrate our technology and ally with a compatible reactor technology, as well as seeking out a GAIN partnership for what would be about $5 million. That moves on to a prototype, valued at $100 million, where we exhibit our combined cycle, contract an initial unit. We're looking at Illinois because they have the most metric tons of uranium, and then move that one step further to manufacture the systems and contract additional units at production scale. We're looking for $5 million. Half of that is facilities and equipment, and the last batch is for operational expenditures such as materials, legal counsel, and staff. There you go.
Well, you get to.
Do I assume some sort of fast spectrum reactor here to eat
exactly.
and fuel rods, right? Yeah. And you $5 million will get you not very far in the certification to operate such a thing. So what comes after your initial study?
Sorry, so I guess I didn't get a chance to explain that on the slide. So the $5 million is our initial proposal for research and development. Then we'll be fundraising additionally once we have our proof of concept for the $100 million in phase 2, and then.
And typically a 10-year certification process in the U.S.?
We'll be working with utilities. That's sort of why we focus on Illinois, as where we're moving our operations to, so we can gather help of utilities and pressuring
Great.
government.
You're going to do that. The guys in Illinois are good at this. So another thing, these spent fuel rods are, as you know, are only 4 or 5% used. Yes. So there's an enormous amount of energy to consume, right?
Absolutely.
and your mobile thing is not going to move very often.
No, that is correct.
Yeah, so I think the cartoon on wheels is a little exaggerated.
That's correct.
I'll just point that out.
So in reality, you could maybe track this in on a fleet of trucks. We're not necessarily limiting ourselves, but
Yeah, skid-mounted, modular kind of thing, right?
Absolutely.
Okay.
I heard you talk about the 50 billion opportunity. I missed how much you think it will cost to do the processing with your technology.
and it's operational once we get going. Or
Yeah, at scale, assuming that you're able to get up to scale.
That was actually in phase 3.
Okay.
That
Yeah.
was 1 billion. So
Okay.
figure out the 20 billion.
Yeah.
1 billion. So I was getting that over 10 billion.
Thank you.
The processing is very costly operation, so we don't expect that just by reprocessing that we will lower the expenses and we will have a gain from that. But we will have profit from the products of reprocessing, from the medical isotopes, from extraction of rare noble metals of spent fuel, from fueling fast breeder reactors, and this is how we are going to make the
Got it. Thank you.
Thank you, guys.
How small do you envision you can make this model? Do you have any idea?
The prototype?
No. The you got a container here, a 40-foot container.
We will discuss with you after.
Good answer.
Okay.
All right. Oh, that's doubling. Next up, we have New World, which will be presented to us by Logan Turk.
Hello, I'm Logan Turk, and I'm here today to talk to you about New World Modular Manufacturing. So I'll have to thank Professor Sachs because he set this one up quite nicely for me. As you see here, the nuclear industry is facing a mounting cliff, and we're going to retire our entire fleet by 2050, and we need to replace that. And not only do we need to replace that, we also need to double that if we are going to meet our emissions targets. So that presents a huge market opportunity for us in the US. Not only in the U.S., it's a worldwide problem as well. So there's an extreme global market that we also see. There's $300 billion currently under construction, an additional $750 billion of reactors planned in the future. So the problem that we're facing is that current nuclear construction is extremely inefficient. Right now, for example, Plant Vogtle in Georgia is about $3 billion over budget and 3 years behind schedule. So that is a serious problem, and it's also contributed to Westinghouse filing for bankruptcy. We think we can do it better. So we're taking a page out of Boeing's book. They make big metal structures much more efficiently than we do in the nuclear industry, and they do it in a factory. As you see here, they assembled their plane very quickly and in an assembly line. So let's do a quick comparison of factory construction versus doing it on site. Some of you may be able to relate to this, but this is IKEA manufacturing and construction. IKEA, you take it to your house, and it takes you a very long time to put it together because you've never done it before. We do the same thing in the nuclear industry, unfortunately. So we need to bring a standardized process to our assembly of nuclear reactors. Let's also compare quality control. Another benefit of doing the construction in a factory is that you end up with the product you want to, not with a chair that doesn't work. So that's another benefit of bringing our assembly into a factory. So we've got the message in the nuclear industry, and there are many designers who are working on this problem, and their solution is small modular reactors. So what we'll do is we'll create multiple small reactors that will be assembled in a factory and then put on a truck or train to be shipped to the final site to be assembled. There are multiple companies working on this. Terrestrial is one of them, TerraPower backed by Bill Gates, but the furthest along is NuScale Power. They've submitted their design certification and secured funding for a 12-module plant to be built in Idaho. So here's what it looks like. We take the manufacturers, kind of like the iPhone industry. They specialize in small parts. They send them all to an assembly line in a factory where it's put together very efficiently, just like us. And then that is shipped to the final customer, just like when you receive an iPhone, the utility customer would receive their reactor. We specialize in the assembly process. So here's the life cycle of that. The utility customer places the order, and the reactor designer fulfills that order. They call up the component suppliers, and then the component suppliers send those components to us. We assemble them together, send it on site, and then a large EPC provider installs it for us. So our vision for this, we are calling the Terafactory. You may have heard of the Gigafactory, and we think we can do 10 to the third better. We'll actually produce a terawatt hour of energy per year in our factory. So the way that we're planning to do this is through a joint venture where we bring together a manufacturing partner to leverage their expertise, financing partners that have the capital for us, and then also the Department of Energy has a lot of funding that they have earmarked for this and are very interested in this project. So we leverage all of these partners together to reduce the risk and make this manufacturing facility. We've assembled a great team to attack this problem and develop the project. We have extensive experience in the nuclear industry, and not only that, we also have many connections that will enable us to do this. We're looking for a seed round of $2 million in funding to further develop this and bring our team to 10 members, and also apply for a DOE loan guarantee, and then we will secure our manufacturing and financing partners. Here, let's look at some numbers for what we project. We look at a positive net income in about 2021, just fulfilling NuScale's initial order. And then by 2023, all invested capital should be returned. And then if we look at our scenario of the mounting cliff, if we get just 15% of the replacement plus growth that I showed you earlier, then we expect to see about $2.5 billion worth of revenue with a $675 million in net income per year. Wouldn't you want a piece of that? Thank you for your time.
How big are these modules, megawatts?
The NuScale design is 50 megawatts, and there are additional designers who are going even smaller, but they will all need this assembly factory.
And there's a cost figure?
For the 50 megawatt?
Yes, that is for the NuScale power modules.
70 million, is that right? How much it costs?
Yeah, 70 million per module.
70 million.
Yes.
Without New World, how is NuScale currently planning to build their reactors?
This. They want someone to do this, and that's because of actually Dylan is joining NuScale soon, and we've talked to their team extensively, and they'd love to see this happen.
For manufacturing partners.
Quick one. What are competitors going to say about having everybody's design built in the same factory?
Everyone designed and built the same factory?
You're talking about being a contract manufacturer for all the different nuclear designers out there. How are they going to feel about sharing their IP or losing their IP by having you build it for them?
I can take that.
Got it.
Yeah, we're planning on choosing the winner, and at this point it's NuScale Power. So if their design for some reason falls through and they don't get qualified,
so you're going to work with one partner.
Precisely.
Okay.
All right, thank you guys very much.
Thank you.
All right, next up, we have Cargatomic. Oh, there we go. Cargatomic, which is going to be presented to us by Monica Rodriguez and Mitchell Sinclair.
Buenas tardes. Good afternoon. My name is Monica Rodriguez, and on behalf of the Cargatomic team, we are going to present to you our startup. First, we'd like for you to take a look around the room, and we'd like to challenge you to find an item for which you can say that was not shipped overseas. It's hard to tell, right? This is because the shipping industry is a worldwide multi-billion-dollar business. But it's riddled with many terrible things. First, we have high fuel costs. It is unreliable because you have delays in your ports, and it is a dirty business. But let's not focus on the problems. Let's solve this. We are the engineering design firm that will couple small modular reactors with big-ass ships. So how will we do this? We will partner with shipbuilders, and we will bring you economical, fast, reliable shipping. The shipping industry is $110 billion. Its delays can cost up to $1 million a day, and new requirements will have you pay double your fuel prices because it will require cleaner fuel. Right now, the global merchant fleet is one of the most polluting entities around the world. It's even more polluting than many countries. New regulations will kick in the following decades, requiring the shipping industry to comply, and they will have to adapt quickly, and we are the rapid response team.
Thank you, Monica. My name is Mitchell Sinclair. I'll introduce our team here. So we have Cliff Gillieri. He's our CEO and board member. Cliff has been an excellent motivator to bring the team to what we are today. We have Monica Rodriguez, who we just met, who's doing environmental and engineering. Pavel Velkovsky, he's our CFO and finance and legal. And Calvin Parkin, he's our CTO, and he is the most brilliant mind that I've met. And Mitchell Sinclair, myself, I'm VP of Sales and Marketing. So, if it's such a great idea, would we have competition? Most definitely. So, currently, MAN Engines is developing diesel and bunker fuels. They're looking to refine their bunker fuel and reduce sulfur emissions, as well as doing carbon capture on their ships, as well as Rolls-Royce Marine Division and Weechaw Power, who's partnering with Westport Engines, develop liquefied natural gas engines for the shipping industry. The advantage that we have, though, is that we're a zero-emission engine solution with zero carbon and zero sulfur emissions. So being environmentally friendly is good, all that, but nobody's going to pay for that if it's not cheaper. So our total lifetime operating expenditures are 5 times cheaper than liquefied natural gas or diesel. Additionally, we have very delighting features, including the ability to sell power from the nuclear reactor on the ship when we're at port, meet environmental and regulation requirements, provide consistent operating expenditures. Especially with a low margin business, this is incredibly important. You don't want variable costs because your fuel costs are going up and you don't know what's happening next year. Additionally, we'll be able to use process heat to treat wastewater and ballast water. We'll be able to ship faster, which means we'll be able to make the port call times and avoid up to potentially $1 to $2 million a day per ship in delay fees on a port. So for a technical solution, right now we've looked at NuScale's. We're open to different partners. But right now, NuScale's reactor is 160 megawatt thermal. We'd use that coupled with a steam turbine to drive the twin propellers on a EEE Maersk class ship. We would use an AC generator to generate AC power when at port, as well as process heat for that ballast water. We have developed a company roadmap. The first 2 years are design and engineering. Phase 3, we are looking at doing a first full-scale engineering and design for a Maersk ship, with phase 4 and phase 5 doing our 2nd, 3rd, and 4th ships. We've developed a 5-year P&L. We're looking for financing right now for $5 million, and then looking for $15 million of financing 3 years later, coupled with $140 million for the engine propulsion system for the ship. I'd like to now welcome questions and comments. Thank you very much.
Yeah, how do you think about safety on board ship? Yeah.
So part of the reason why we went with the NuScale module was because unlike some of the military ships that use high enriched uranium, NuScale actually goes with 3 to 5%, just like on regular light water reactors. So on a safety standpoint, that's actually much safer, and in a safeguard standpoint, much safer than what's currently available. Yeah, anyone? Oh. Yeah.
But 3 to 5% guaranteed
Yes.
safety? I don't buy that one, right? So is a passive shutdown on this? Or?
So we'll have a typical solution that nuclear plants go with, which is just higher guns and guards for the ships as well. And that means your cargo is going to be even more secure as well.
from a technical standpoint.
Okay. How often do you need to refuel?
So the NuScale reactors are on a 2-year refueling process, but since we won't be operating at full power during cruising, we'll be able to extend that quite a bit.
What specifically are the laws that are driving your business, the laws for cleaner emissions?
So currently, sulfur emissions, the global shipping fleet is about 50% of those. There's going to be caps on those imposed by 2020, where they're going to look to cut to those significantly. And low sulfur fuels, as well as liquefied natural gas, are significantly more expensive than the current bunker fuels that are used for them.
And another question, will these ships be able to make port in an anti-nuclear country like Germany?
Well, the size of the ships that we're using are, the limiting factor is actually the size of the ship, less the being able to make port in anti-nuclear countries. I think that in terms of countries that actually ban nuclear ships from their waters, there are relatively few, like New Zealand, like perhaps Germany, but I don't think any of the countries where we might,
The first few ships will demonstrate the safety and reliability of the technology, and then we're hoping that that will speed up the process of getting approved to come into port in other countries.
What were some of the main drivers of costs that you considered in your calculation about cost savings?
Cost savings as far as we're expecting that there'll be emissions caps on greenhouse gases, which there are lots of modifications that can be made to these ships as far as making them cleaner emitters. But the only actual solution that we're offering is 100% no greenhouse gas emissions, no sulfur dioxide, no nitrous oxide, 100% across the board. No matter how regulations change, our ships will always be ready to sail. Yeah.
And also, LNG right now has about half the energy density of the fuels that are used, and that takes up plenty of your cargo space. And these ships are driven by economies of scale. You need a very large TEU to make it cost effective. So if you have a lot of fuel taking up cargo space, you're also reducing your margins.
In which shipyard do you think you would be able to build a nuclear-powered ship?
Sorry, Alan, I'm going to have
Asia.
to have them.
South Korea specifically, Daewoo.
South Korea is your answer. And with that, we're going to go on to the next group. All right. Next up, from Nuclear Perceptions, please welcome Logan Smith.
Thank you.
Down button.
Down button, nice one. As we know, I'm probably preaching to the converted here, but nuclear energy is going to be a big part of the way we generate power. It is a big part of the way we run our lives, and it's going to be a big part of how our way of life improves. Obviously, to maintain this way of life, we're going to need to invest in advancing our nuclear technology, and of course doing this is going to improve our engineering and scientific capabilities in other areas. So our idea here is to create a company called Nuclear Perceptions, which is going to be our platform for promoting nuclear technology to the common people. Hello, my name is Logan Smith, and this is my co-founder, Zhao Jin. So nuclear is great, we all know that. Why do people not agree with us? We spent the last couple of months just canvassing people on the street, finding out what were their biggest gripes, what were their biggest concerns with nuclear power, and these were the big ones. Obviously, there's plenty of anti-nuclear groups out there that are going to reinforce those opinions. Greenpeace and Friends of the Earth are the two major international bodies, and there's also individual advocates as well, such as Helen Caldicott. And this all trickles down into popular culture. Interesting to note, actually, HBO just in the last couple of days have announced they're doing a 5-part miniseries on a dramatisation of the Chernobyl disaster. Now, there are plenty of organisations out there that try to provide interesting and balanced, realistic information on what the nuclear is all about. But most of us in the West, we're time poor. We don't have time to go looking these up and read a document about it. So we believe our solution to this is to create cheap multimedia that is available and is pervasive. So what do we mean by pervasive? Well, we think YouTube is a prime target or a prime platform to achieve this goal. It can effectively reach worldwide, and it's a good platform to reach the 18 to 34-year-old market. And our target market initially is going to be the US, but we can very simply change it or expand it to a larger audience. So what we're going to produce are two main products. We've affectionately called them Jimmy Vids and Billy Vids. Jimmy Vids, named in honour of Jimmy Carter, who was your 39th president and nuclear naval officer. Those videos are going to be for education and entertainment. Also, Billy Vids, named in honour of Bill Gates, of TerraPower and Nuclear Advocate. They're going to chase the volume, they're going to present simple messages, and they're going to advertise our product. In the future, if we can grow our brand, we've got several other ideas of what we'd like to do for products. But coming back to what we're starting off with, a Jimmy vid, something that's 3 to 5 minutes long. You might get 2 videos every month, that's what we'd like to aim to produce. And it's going, and this is the pervasive part, going to be related to nuclear industry and how that can hook into popular culture. For example, we could look at the Incredible Hulk, who was Bruce Banner mutated by gamma radiation, and we could have a discussion on how gamma radiation really works. Another idea could be Fallout 4, a video game about a nuclear wasteland. We could make a comparison with current day Chernobyl. Finally, perhaps everyone loves Star Wars. What about Darth Vader's Star Destroyer? What sort of nuclear propulsion system would it have to run in a realistic sense? Coming back to advertisements, so the Billy videos, we're looking at short ads, paid to go out to a large audience. They tell a story, they deliver a message, and they can link back to basically draw more attention to our primary or our initial product being the Jimmy Vids. Initially, to get us going, first year we'll need about $240,000, but if we're just doing the first quarter, all we're asking for is $50,000. We'd like to partner with all these other, plenty of other national laboratories, not only in the US, but also abroad. But our initial funding, we think, is going to come from the nuclear operators. These are the people that really could do with a strong advocate for nuclear power. So we think we could be that advocate for the industry. Thank you.
So you're going to compete effectively with marketing companies. These nuclear operators could just hire an already existing marketing company, correct? So how do you plan to compete with them?
Sure, they could do it. They don't seem to be doing it at the moment. Our idea is, as I said, there's plenty of information out there already. People generally don't seem to be getting the message. We have an idea, make pervasive videos, get into the minds of the young people, get people talking about it.
Okay, thanks.
Judges, any additional questions?
Could you comment a bit on the type of relationship you anticipate with NEI or ANS?
Yeah, sure. Ultimately, we would have to start small, get some videos out there, get some eyes on there. But yeah, we could approach other companies, say, hey, look, this is what we produce. We'd love to talk to you. Future products, we'd love to be able to be invited to a laboratory and explain to the people what they actually do. It would be a very good way of getting young people interested in a career in nuclear science or anything technically nuclear related.
What would be, so your revenue stream would be getting hired by those other companies that are producers to do this campaign for them, basically?
We will, for all the videos, it's very low cost. So primarily, in the first, we will make the videos ourselves, and then we'll hire. We already include all the costs to hire the consulting firms, including the legal one and the media one and the website one.
Thank you.
Thank you.
All right, thank you guys.
Thank you very much.
All right, last but certainly not least, we have Atomic Analytics, who's being presented to us by Katie Muma. Thank you. Down one. Down one. Yep.
The nuclear industry is unique. An event that happens at any plant affects the entire industry. This is not how other industries work. If the Ford F-150 had a safety recall, you wouldn't turn and look at your Toyota Prius and worry that it's unsafe. But this is exactly how the nuclear industry works. An event that happens at a single plant changes the perceptions of the public and the regulatory structures at every other plant in the US and potentially even the world. So there is a reason for nuclear utilities to share their operating experience to try to prevent events from happening at other plants, even ones that are not within their company. This is already being done, and this information is being shared through existing database structures. But the problem is, these existing databases are clunky and difficult to use, and if it's hard to search for the information you're looking for, you can't find other events about a particular system or component. We are going to solve this problem. We are going to make it extremely easy to locate events that have to do with a particular system or component, particular type of pump, for example, and automatically pull up similar reports, as well as automatically generate graphs that come from data analytics. As I mentioned, there is existing database structures, and how this works is all of the nuclear utilities pay an annual subscription fee to the Institute of Nuclear Power Operations. And one of the things that INPO does is it accepts all of these event reports and puts them into a database, a very large database. But because it is not easily searchable, utilities cannot pull out more than 1 or 2 reports at a time. This is where we come in. We are going to make it easy to get value out of this existing database structure in exchange for a small subscription fee onto what they already pay to INPO every year. We know there is a market for this. Even the generation of these event reports costs each plant $800,000 a year. And any event that causes a forced outage where the plant goes off the grid costs the plant more than $1 million a day. So even if we only capture 5 to 10% of this market and reduce the events by 5 to 10%, we will save utilities hundreds of thousands of dollars a year. We are asking for $1 million in seed financing. This will get us through our first year and all the way to our Series A financing. This will allow us to hire 2 software engineers, to do market research and develop our full cost analysis, and start building our software platform. We are Atomic Analytics. My name is Katie Muma, and I am the CEO. I bring reactor engineering experience from my time interning at Oyster Creek Generating Station. Our COO is McKinley McCabe, who has an experience in coordinating teams and creating technical documentation. Our CTO is Courtney McLean, who spent a year working at a commercial plant in Canada, working with these event reports every day. And finally, our CFO is Ari Kraus. He brings startup experience to the team, having co-founded a startup before, and has experience in financial projections. We are going to do this in a 3-step process to help get us to market as fast as possible. We are going to bring the search features and data analytics right away, and then start earning revenue within 18 to 24 months. Then we will move into step 2, which allows us to refine our features, partner with IBM Watson, and then go ahead and actually automate some of the event entry, saving more money for these event reports. Finally, when we have a sustainable revenue stream, we are going to take our product global. It is very, very difficult to share operating experience across international borders, but this is what we are going to do once we've developed a sustainable revenue stream. Again, we are asking for $1 million in seed financing. We are Atomic Analytics. Thank you, and I will now take any questions.
Do you have any idea of what additional fee you would want to charge on top of the subscription they already charge?
We'd probably figure out this fee during the initial market research phase, because as many of you know, the nuclear industry is not very forthcoming with any information, including how much they pay INPO right now. So we couldn't really get an exact figure to give you.
Okay. This is all pretty reactive. You're reporting on events that have already happened. Is there an opportunity? I see you're using Watson, but effectively this is just a very sophisticated search, but perhaps doing something predictive could be an expanded market opportunity.
Absolutely. So in our third step, we're also going to partner with some of the plants are starting to do active component monitoring. And so the combination of these existing event reports and active component monitoring, which right now has no overlap, but when we start bringing those together, that really starts to give us the ability to do this predictive capability. So that is absolutely something we're looking for once we have already worked on developing a sustainable revenue stream.
Do you understand the INPO database and what that looks like?
We have several people, myself included, who have worked directly with operating experience and these event reports before. I have used the database once myself. I have used internal databases, and as well as we have talked to industry partners who have told us, directly that they find it.
In the industrial world, people use these time series of events that they can then go back and figure out what happened. Something blew up, or this pump failed, and do that. There's a lot of GE Predix is one of the current products that people are developing to do this stuff, right? And there are specific databases for that. For example, a Pi historian is widely used in power plants, and my guess is almost all these plants you'd find that, and that stores these streams. One of the major problems with those databases is that they've grown up over 30 years, and there are different names, and try to get all that sorted out is a major challenge. But it's extremely valuable to your point if you can get that operational data and then share that.
Right, and again, we absolutely want to start integrating that.
Yeah.
Active monitoring that's occurring.
If you look at an ExxonMobil type company, they're trying to do exactly that on all of their stuff, so that they can share that from site to site, right?
Yeah, other industries do this, so there is a model outside of the nuclear industry to do stuff like this.
Not the nuclear guys.
Yeah, not in nuclear, so we will follow other industries and see how they're approaching this issue.
Like we do in so many ways. Thank you very much, guys. Professor, do you want to come over to your computer? All right. All right, while we're getting set up here, you can see the judges are heading out. They're going to go deliberate. Milish is looking for any additional questions from here in the audience. Milish, you've got one up here. All right. So, while you finish getting set up, I'd like to introduce Arun Majumdar is the J. Precourt Professor at Stanford in Material Science. It's okay, guys, that he's at Stanford. It's okay, he went to Cal. more importantly than the whole Stanford thing, he was appointed as the first director of the Advanced Research Projects Agency Energy, which is the program that makes energy moonshot everything possible in the Department of Energy. To me, in a lot of ways, it seems like ARPA-E is the grown-up version of Nuclear Innovation Bootcamp if they did nuclear things, which they will. You good to go?
Sure.
All right, I'm so happy and excited to welcome Professor Arun Majumdar to the stage. Thank you.
Well, thank you for inviting a Cal graduate to Cal. In fact, they have a long history, not just as a student, but as a faculty. I got married out here. My wife is a Cal graduate, but I'm at Stanford right now. It's delightful to listen to all the teams that we're presenting, and I want to thank Rachel for putting this together, bringing the next generation and giving and offering an education which is beyond just technical. And I was just been looking at your program, and I think that holistic view of things is so important in the days that we're living in today. And I'm sure you're breathing a sigh of relief now that after 2 weeks it is now coming to a conclusion. And I suspect the only reason you're here on a Friday evening is because there's a reception at the end of this. So, thank you. Can you hear me properly? Great. I thought I'll give you my perspective looking at the energy industry. I'm not going to tell you too much about nuclear. You guys have already heard about it. You had 2 weeks of that. But how does nuclear fit into the larger context of energy? And I thought I'll give you my impression of looking at it for more than probably a couple of decades of this, but more intensely over the last decade. So I call it navigating the turbulence, because those of you who have, how many people have taken turbulence classes? Well, Pierre, of course, you and I did it together, I think. But you have certainly felt your turbulence, and it's a bumpy ride. And I believe we are in a bumpy ride for the next couple of decades, which, by the way, is an amazing opportunity. So the first thing I want to invoke is another Cal graduate who wrote a very famous book, and I want to ask you, who has read the book written by this other Cal graduate, Andy Grove? Only the Paranoid Survive. If you have not read it, it is worth reading. And he describes in that a world that he went through at Intel, when Intel was going almost under in the 1980s. When the fundamentals of this business changed. And he called it a strategic inflection point, where there's an inflection point in a strategy, in this case, a business. It could be an industry, it could be a country, it could be the world. And the idea is that the inflection point in strategy means that the strategy that one had before doesn't apply anymore. The fundamentals shift. And so you can't look at past data. A lot of people say, oh, let's look at data. The past data is of no use, of little use, because it was for the previous world. And if the fundamentals have changed, you got to think differently. And not only you got to think differently, you got to try some experiments. And the strategic inflection point may seem very close in the beginning, but how you adopt the new fundamentals can get you at two different places, okay? And I think the energy world is going through one of these strategic inflection points worldwide. Why is it doing that? There are 3 drivers for this, and I call this the 3D effect. 1D is decarbonization. This is the Paris Agreement. I mean, it took 21 meetings, believe it or not. to agree, to acknowledge that there's a problem. And that first is decarbonization, and regardless of the fluctuations, the political fluctuations, which almost seems like the Keeling curve, right? The fluctuations, but there's a trend. And that vector is pointing in the direction to decarbonize the energy system or economies. And that is happening through various means. It is the largest industry in the world. It is roughly $10 trillion a year. The second D is digitization. And this is the word that we saw a little bit, we just heard about it. But this digitization is you could say it's a spectrum starting from the 1700s of automation. And this is another version of automation that is coming, and that is going deeply into the energy world, whether it's oil and gas, whether it's transportation. The transportation ones we see because we use Uber and many things, which is, I think, just the start. There's much more coming, but it's in the electricity world as well. And the third one is diversification. People are diversifying. I mean, transportation used to be only, oil and internal combustion engine. That is shifting, and that is shifting to the point that it is there are much more consumer choices. There are many more choices for electricity generation, and that is not only a good thing for the consumers in terms of consumer choice, it is a tremendous thing for national security. And when you're talking about energy, you got three securities that you have to take care of. One is the economic security, the second is the environmental security, and the third is national security. You can't ignore that. And so this is the realm we are in. And after 100 years of enormous success of the industry that has led to economic growth, this is shifting. And if you talk to the people, let's say in the oil and gas industry, which I do a lot, to find out what are they thinking about. And you find that you go to these global industries, you go to the shareholder meetings, and you'll find that half the time they're trying to answer the question when the shareholder is asking, what are you going to do about decarbonization? What are you going to do about climate change? And this is going on as we speak. So they're under tremendous pressure, and the whole business is based on carbon, and then suddenly they've been asked, how do you decarbonize? This is fundamental shift that's going on, and this is going on globally. So these are the changes that are happening, and yet we have some challenges. You may have seen this is where the people live. This is where electricity is used, which is a proxy of economic growth, and you see a mismatch. And there are three grand challenges that we have. How do we continue our economic growth while we reduce our greenhouse gas emissions? So you decouple the two. We have sort of decoupled in the United States, but many parts of the world have not yet decoupled. How do we provide access to affordable modern energy to every human being in the world? That should be a human right in the 21st century. And then number three, how do we make our energy system reliable, resilient, adaptable, secure against various threats? And climate is one, cyber is I don't have to even tell you that, cyber is a big threat. So you got these three drivers of change, which are sort of pulling the rug out of people's understanding. And you got these three grand challenges. And the big paramount question is, how do we create pathways to address the grand energy challenges and navigate this 3D landscape? This is the challenge. And people who are sitting whether in the oil and gas or transportation industry, their revenue is coming, the profits are coming from a certain sector, and the shareholders are saying, you got to shift. So they have to continue their businesses, and at the same time, they have to think, how do we pivot? And no one really has the answer today. Okay, that's the world we're living in. So what do you do? Well, since you're in the Bay Area, I got to tell you something, that you look for strategies, and one of the best strategies I can tell you is what happened in the Bay Area. You need a Steph Curry. And those of you who don't know Steph Curry, let me tell you find out who he is. Because in the Bay Area, you need to know him. And this is where, by the way, his point shots, his percentage, and the number of shots he takes and the percentage of winning. And he's not perfect, but he's pretty close to it. But you can see gaps out there. But in that, you add Kevin Durant, and suddenly you find this map to be changing a bit, and you add Klay Thompson, and you keep adding, and suddenly you find that this thing is filling up, okay? So what's the strategy? The number one thing, which we saw a little bit earlier, you need talent, okay? You need talent, and this is from our experience. Some of us were there in RPE, our experience in RPE. The number one thing, you need talent. The number two thing, you gotta nurture the team of talent. It's very important, the environment that you create for nurturing. Because talent, if it goes in different directions, can give you bad things. So you gotta sort of harness that and direct them in a certain way. How do you nurture is very important. Creating the right culture and environment is very important. Not enough attention is paid to this culture part, but absolutely, we are all human beings. And how you create the social part of it is as important as the technical part. In fact, you may not get the technical side if you don't have the social side as well. Creating opportunities for multiple shots at the basket. And that's very important. I mean, you can't win it with one basket. You've got to take multiple shots because not all of them are going to win. So portfolio of approaches, we have some simple layups, but you also have some unbelievable three-pointers. You got to take that. And so this combination of a portfolio is very important. And that's, in fact, from our experience in RPE, what did we look for? We'll look for things like this. And I'll give you an example that many of my colleagues take, that if you look at the technologies that were developed, this is the horse carriage. We then created automobiles. And way before the automobiles became popular, there were many examples of automobiles that were tried out, steam-powered, the Benz motor wagon, but these were very, very expensive. They didn't go anywhere. Until the Model T, in the manufacturing, someone talked about assembly line. Well, this is where it was invented. And it brought down the cost and improved the performance to the point that it was faster, better, cheaper than going on horses. And I think that's the key message, is that you got to try some shots at goal early on, and you may fail. That's okay. But amongst that, something will happen, and that is bringing down the cost and performance, increasing performance, and you become disruptive to the industry. And this is a great example. These are pictures of New York City in 1900. And you can barely see an automobile. There's one red circle. That's the only automobile in 1900 New York City. That's in 100,000 horses, 1,200 tons of manure per day, okay? 100,000 liters of urine per day. Talk about an environmental problem. Those are the heaps of manure, horse manure out there. This is 1900, and this is New York City in 1913, okay? In a matter of, and the Ford Model T was introduced in 1908. 5 years. Talk about disruption, and the horse business got disrupted. Okay, and it's faster, better, and cleaner. It's cheaper, it's cleaner, and that's what happened. And there's some lessons learned out here. What actually led this to this amazing transformation? But it started long ago, and some of it may not look quite, what's the phone call? It's my daughter calling. So that's, you see this amazing transformation happen. So what are the different stages? And I think those of you who are interested, I'm so glad you're interested in nuclear, but you got to realize that a technology goes through various stages. We heard a little bit of that. Early stages, you need a portfolio. You need about a few $1 million, as we heard, for a few years. But as it progresses, you have a proof of concept, you have a proof of system. The proof of scalability is very important, because in energy business, if it doesn't scale in volume and size, it doesn't matter. And it costs more as you go downstream. Supply chain development, regulatory compliance, talk about regulatory compliance in nuclear, that costs money. And then, of course, product and services and the markets. And you may do the early stage at the university, but later stages, at least in the energy sector, the private sector has to come in. There are all kinds of tax policies. I won't even go through that, but that's the nature of business out here. And the question you're asking is often, it takes 20 years to go from something at a university downstream to get really scaled up. The question is, can we shorten that in some way? Because the investors in the early stages from somewhere out here not going to wait for 20 years for the returns. So how do you shorten that? Very, very important. And this is what we think it's going to happen. This indeed has happened in the solar business. As you increase the scale, the cost has come down. The nuclear business has gone the other way. This is some data from France. It's gone the other way. And this trend has to shift. This has to change fundamentally because the learning rate is negative in the nuclear business. The question is, why is the learning rate negative? We did a report for Secretary Moniz end of last year. This is probably the last report we did as part of his advisory board. And we had a whole section of what controls learning rates. Because in South Korea, nuclear is going the other way. It's going the right way. So why is it that in South Korea it's going this way, in the United States and in France and all it's going the other way? And I'm not going to go through all this, but this is not one reason. It's a factor of like 10 reasons, 9 or 10 reasons that all come together. But going small modular is a good idea, and for a variety of reasons, but it has to be more than just small modular. But all the electricity, I mean, at the end of the day, nuclear has to connect with the electricity grid. So let me tell you what's going on in the grid, because that's very important. This is the vascular system of any modern economy. The grid that we have today started about 120 years ago, and the architecture, not the devices, but the architecture has remained the same. It's the architecture of Nikola Tesla and Thomas Edison. It's the Tesla-Edison paradigm, where you have centralized generation, long-distance high-voltage transmission to medium voltage distribution in our feeder lines, and then low voltage use in our homes. And there's only one-way power flow, and the generation always tracks the load, so you can turn on a light and some generator has to ramp up. And the only way to communicate at that time was frequency. And so if you turn on the load, the frequency goes down a little bit, and some operator in the generating station has to ramp it up to bring it back to 60 hertz or 50 hertz, whatever that may be. And so that's been the paradigm that we're living in. But because of these drivers of change, and the drivers of change, as we talked about, is decarbonization. And so what are the options we have? Well, the options is to go to deep renewable penetration. California has decided to go more than 50%, 50% 2030, and now they're talking about 100% by 2045. Boy, that's going to be hard. And we really don't know how to get from here to there. And that's going to be, could be expensive as well. Nevertheless, renewables is one, demand side management, that's carbon capture and sequestration, or nuclear. We really don't have more choices than that. And the other driver that is changing in the electricity system is deep penetration, or increasing penetration of distributed resources, not just solar PV, but just contact points that are networked that you can control, like control thermostats, etc. But in terms of the top part, what are the options? Economics, because markets do play a role out here. What is the cheapest? This is what's going on. You have wind prices come down. These are contract prices. This is data from business, and it's approaching the point of about $20 a megawatt hour. Solar is also coming down, and there's headroom to bring down even further. What do these numbers relate to? Well, this is where US natural gas and China coal is, and this is where US coal and nuclear are. So these are the prices. Now, these are the long-term contract prices, but on a daily basis, how does it work? Can nuclear dispatch into the grid on a daily basis? Well, this is how the markets work. And I'll be very simple picture. Here's how the bidding that happens in a market goes according to a marginal cost. And because solar and wind have no fuel, the marginal cost is zero, essentially, close to zero. There's some operating cost, maintenance cost, et cetera, but close to zero. So they go bid lower, that's part of the demand, then natural gas goes, then nuclear, and then coal. And whenever the demand, the supply meets the demand, that's the price, and the rest of it is revenue. So you can go marginal cost really low. So the first thing that gets adopted is solar and wind, then natural gas, and if there's space for nuclear, nuclear gets dispatched. If the load does not increase, okay, it's very hard for nuclear to compete today, except if you put a carbon price. If you put a price on carbon, this thing flips. And if it flips, then nuclear will go before natural gas. And that is why it is so important that if you have markets going on in wholesale, you can't not have a price and try to play in the market and try to decarbonize. It's trying to really run with your legs tied. Okay, so that's what's going on in the industry today. And unfortunately, nuclear is not making it in many places unless there are some subsidies or something. And frankly, there are subsidies for solar and wind as well. So this is a big deal, because if nuclear does not dispatch, there's risk of shutting down, which is what was going on in New York and in Illinois till the state intervened in them. So this is a big challenge for nuclear, and I really hope that at some point we get a carbon price, and no matter what people say, coal ain't coming back because it's just too expensive. But because the renewables are getting integrated, because there are these mandates that we want to get 40%, 50% renewables, this is what goes on. The sun rises and it comes down. And because of that, you have what is called the duck curve. How many of you have heard of the duck curve? Well, everyone's heard, so I don't have to say anything. But there are some problems with the challenges that the duck curve offers with the grid, which the grid has never faced before. And that is because you have overgeneration during the day, and you have a massive ramp in the evening. So all the other things that if these things get bid and gets adopted the first shot, the other electricity generation services have to adapt to this. That's the world we're entering. It's not baseload power always that is important. It is ramps that is very important, and trying to load shift that is also very important. So load shifting, ramping are the new services that will have to get amplified in the wholesale market in the future, will get amplified. So if you look at the grid architecture where nuclear has to play, this is what is going on. This is what it used to be. You got the wholesale market, and you got people bidding in. You got generation, transmission, substation, distribution. You got the homes, and you have a wholesale market. The utility, it's not really a market, but the prices are fixed by the utility commission, and this is monitored by the federal, in this United States, the federal regulators. This is monitored by the state regulators, and it comes to the meter and it stops. And what we're now trying to do is to inject huge amounts of solar and wind into the grid, which it was not designed for. It's volatile generation, not stable. And on the other end of the grid, you got volatility in one end, you got volatility at the other end as well. Because now you can control and turn up and down large amounts of loads on negative loads, which is generation, and they are all connected to the cloud in the computing world, and which means that you can collect the data, you can monitor, you can analyze, you can control, you can turn up and down large amount of loads, you can aggregate. And once you get aggregation, you can then sell those services into the wholesale market or to the utility retail market. So what is happening is that the wiring system of the grid is completely changing. It's getting rewired in a different way using information. That is what is happening, and it's going to happen even more and more. And of course, along with that, you get cyber threats that is happening. And it's unbelievable how many times, let's say PG&E gets pinged in a cyber threat on a daily basis. It's unbelievable. So looking at this grid, and this is where nuclear has to play. So we at Stanford looked at this and said, this needs some holistic approach, not just technical, but you got to bring the markets, you bring the policy, bring the regulatory side. And we created an initiative, launched it last year, called Bits and Watts, which really looks at the holistic view of it. And of course, as the name suggests, bits and watts is very important, because bits are going to be controlling the watts in the future. But coming back to the nuclear, let me just end with a few things, and end with some of the observation that I just made in the previous session. The opportunities that nuclear provide are clear. The largest carbon-free source of electricity, we all know that. The largest carbon-free source of process heat, this is not appreciated enough, because process heat is going to be the most difficult thing to decarbonize in the future. I think we have options for electricity. It's very hard to find options for process heat in the future that you want to decarbonize. So this is going to be very important. We're on the way to small modular, which I think is a very good trend, because you can do the things that we just heard a few minutes ago. And believe it or not, I don't have to tell you, preaching to the choir, it's high safety. Okay? This is the advantage that we have. But there are some challenges. And challenges means opportunities. It is expensive. We saw the picture of the Vogel plant, and the Vogel plant is going at what, $7 or $8 a watt? And whereas other sources that it has to compete with are much cheaper, if you can get to baseload power of $3 a watt, that's going to be competitive. But we don't really know how to get there from the construction point of view in the current regulatory system. We heard about delays in construction. It is absolutely true, and you can look at the data not just in the United States, but worldwide. The time for regulatory approval and the process for regulatory approval, we are the gold standard in the Nuclear Regulatory Commission. This is the gold standard for the world. We think the UK is better. You go and talk to the UK people, they'll tell you the US is the one that is the gold standard. But boy, it needs some improvement in terms of the process. There's a question about waste management, and this inability to ramp, which I think is a myth, which can certainly be addressed. So all of these are challenges, but this is where, for the younger generation that is here, this is where the opportunity also is, because there's no reason, there's no law of physics that tells you the nuclear cannot be ramped. After all, we do that in our ships and submarines. So tell me a reason why nuclear cannot be ramped. There's a rather big debate going on, email traffic's going on about ramping, and I don't see at least any fundamental reason why it cannot be. And that would be one of the best things that can happen in nuclear. If in the mix of the grid we have volatile generation, if you can have the ramping capability, that really sort of jives with the new kind of nuclear that we can have. A lot of people say this is impossible. But let me remind you of some of the predictions that very famous people who are making now, but very famous people made in the past. These are called famous or infamous predictions of the past. This is Lord Kelvin in 1890. Radio has no future. X-rays will prove to be a hoax. Heavier than flying machines are impossible. Lord Kelvin was very opinionated. But he was dead wrong. But he was convincing to many, because he convinced Wilbur Wright that man will not fly for 50 years. Luckily, he had a brother, Orville Wright, who proved, and they jointly proved themselves wrong. One of the best quotes I have seen is by Arthur C. Clarke: any sufficiently advanced technology cannot be distinguished from magic. And it is really for us and all of you to do some magic. But let me end by what I just heard, by a quote from Margaret Mead. Never doubt that a small group of thoughtful, committed citizens can change the world. Indeed, it's the only thing that ever has. Thank you very much.
Yeah, we're going to have some of the students come up, and if audience members have questions for you, they can write them down or raise their hands. You're welcome to join them over there if you want.
This is the Q&A for them. So how is it going to run?
Do you want to have questions asked of you?
Yeah, sure.
Pass down. All right, so I have some questions. Yeah. So I have some questions that I collected from the audience earlier. We're going to start with one that went kind of across a number of your guys' companies, which regards policy changes. So specifically we had to Cargatomics about unclear shipping port use permissions. We had for New World, you guys mentioned DOE loan guarantees, but those are currently on the chopping block in Congress. And Condor, someone in the audience says that what you guys propose is currently not legal under the Nuclear Waste Policy Act. So in light of these topics, question, how do we deal with policy? How do we address it? How do we change it when it needs to be changed or when we want it to be changed? And what role do you guys see your companies have in that effort?
So I'm with Cargatomic. So the initial argument that that policy will restrict the nuclear-powered commercial fleet from operating is not necessarily going to be an issue. Our ships, the ships that we're aiming for are some of the largest ships that have ever been built on Earth. And right now, those are restricted to very few ports on Earth. So there's no restrictions on any of those very, very large ports for nuclear vessels entering. In the future, perhaps there'll be other models of ships that would be built, and that would then pose an issue. But as it stands, we would have free reign of the seas for the big ships.
I'm Dylan from New World, and to DOE funding, we'll certainly seek it where it's available. NuScale Power's funding comes 1/3 from the DOE at present. That's going to be cut in the next year, and 2/3 from Fluor, which is a giant petrochemical corporation. And so we'll seek it where it's available through the GAIN initiative, through partnerships with universities and accelerator programs, which we learned about today in universities. That can help us get these first steps done, but really it seems like the private investment from other oil companies, from other energy companies that want to get into this game is where we're going to see our funding. So, policy-wise, we'll make inroads where we can, but we got to rely on private industry to do a lot of the heavy lifting.
So I'm coming from Condor. Policy is our biggest challenge because we are proposing reprocessing, and also we are dealing with the current waste disposal concept. However, our strategy to deal with this challenge is to first pursue or go with to the utilities. So, because what we are taking off of them is the fuel, so they don't have to take care of all the security measures and all the money that they will have to spend each year. Also, our concept introduces a much cleaner way of disposal. So we have huge environmental impact here. And with the help of the utilities and also from original communities, because we were introducing, or we will have employment growth in the regions where we are going to our mobile facility in and reprocess the already spent fuel. So within this help, we are targeting then the NRC, and we will push a little bit with the help of the utilities to change the current policy framework.
All right, hopefully that addresses your questions. Nuclear perceptions. How are you going to break into the echo chamber about nuclear and nuclear energy?
I'm not sure what you mean by break into the echo chamber. We are in the echo chamber here.
All right.
How we could break out of the echo chamber?
chamber?
Well, that's the thing. Get into the popular culture. Get at least the young generation talking about it. Get them sharing it with their friends. Get people talking about nuclear. Get people having discussions about it. Once you get it into the public eye, people are talking about it, and it's not just all nuclear are bad from Greenpeace and whatnot. The policymakers, your people in government, I believe you guys say on the Hill. Once those guys say, oh my God, I heard something about that, let's fund that. I believe one of your other scientists, Neil deGrasse Tyson, when talking about science, when getting out into the public talking about science, people up on the Hill say, oh, I watched something on John Oliver or one of your variety programs. I heard about that. Let's fund that. Let's vote for that. Let's do something about that. That's how I think you get it out of the echo chamber.
But given that, and I'm building this off of the presentation that you guys had from Todd Allen about risk and risk perception. Since most of the people, what they're going to have heard about nuclear is going to be about the risks. How are you going to bring the fact that you want to start from what people have already heard in line with what Todd taught you guys about don't talk about the risk because that just makes people think about the risk?
Look, I know one of our things is we'll probably need some other skills, so clever people with marketing, but yeah, there's definitely ways that you can fudge the language, well, not fudge the language, there are ways that you can use selective language that you're saying the same thing, but it's all of a sudden palatable to the masses. It doesn't make them run a mile.
Got it. All right, atomic analytics. What about international plants? And incorporating international plants and information from international plants into what you guys are talking about? What would be the benefits or what would be the challenges?
So there are absolutely both. So as we mentioned, this is not something we're trying to tackle right away because it is not easy. It is a lot harder to share information across these international borders. However, only about a quarter of the plants are in the US. So that just adds so much more information, so many more events to analyze. So there are certainly benefits just from sheer volume. And different cultures also operate their plants a little bit differently. There's great analytics to be had there. But as we mentioned, it is not easy. It will take time, it will take lawyers. So it would be something to build up to over time. Does that answer your question?
It answers it for me. Hopefully it also answers
I
it
hope
for whomever
that was. Does that answer what you were asking?
Athena, and this is a question that I actually had as well. How are you going to ensure that the radiation isn't going to degrade your sensors in the RFID chips?
So that's one of actually our biggest concerns that we face when talking about the technology. We actually have found labs here in the US that put similar type of devices, different type of technology in terms of the location, GPS versus RFID, but they actually put electronics directly onto the sources, directly into really hot waste casks, and they use it for shipping and their transportation. So we've taken most of the solutions involve heavy casing of the apparatus, but that we've identified that as one of their biggest concerns for the technology.
Okay. I'm going to ask one more question of you guys as students, not as representative of your companies that you pitched. What is the most interesting or surprising thing you learned over the last 2 weeks at boot camp? Bueller.
Maybe not interesting or surprising, just so much as it was a magical experience where, like, we don't have this environment anywhere else to have it's a kind of a hippy dippy way of saying it, but a safe space to have crazy ideas. Like, if you don't have that space, then the crazy ideas never happen. So just being able to be a part of that was quite magical.
So I guess I'll go more towards the interesting. So I knew nothing about business or finance or marketing, and we got so much of that, and that was like straight learning. All of that was brand new to me. I had no idea how complex it was, and it was just an area that I was previously like, that is outside of the bounds of what I know. So it was just amazing to get a lot of background in those areas that I just had none at all.
I think one of the best things I've learned is that coming from a technical background, doing engineering, we might all be very familiar with how our designs might work and how the technology challenges can be addressed, but there's a huge role in bringing these ideas to the table and bring them to fruition, and that's all the other side of things, the business side of things, the political issues, the regulation, and I think this whole course during 2 weeks really addressed those issues.
I didn't know your naval propulsion systems were enriched to 90% uranium. That blew my mind.
So coming from a technical background, I have a technical background as well. I didn't know a lot of things business related, so I learned a lot. But the most important thing that I learned is how to communicate my idea and how should I communicate with other people within the group. How to put aside my ego and how to make a step back and how to do strategic pivots. So yeah, this is the most important thing.
I also have a pretty short answer. I was very surprised to learn how possible everything actually really is in the nuclear industry, with innovation, with everything. That was really cool to hear about all the progress that's being made. All the cool ideas everybody has.
Now, I just want to add one final thing. I've noticed this before. As a nuclear engineering student, you don't get a lot of opportunities to interact with people in the nuclear industry outside of your country. And I've only had one other experience, and that was because I left the country to go do it. So this was really incredible just in the other people that are here with us. We have so many different countries represented. And so just getting to interact with them and see their perspectives as we go along this journey together was really beneficial.
All right, well, thank you guys. We're gonna cut off Q&A there to try to stay close to on time.
Thanks, everybody.
And I know that these 6 students are representative of the 25, but not representative of all of the things that the students have had. So I encourage everybody who's here in the audience to talk to them after this or to message them. If you tag bootcamp, we'll make sure that they see it. If you have questions for them about what bootcamp was like, what they learned, things along those lines. Right now, I think this is the most exciting moment, but maybe nerve-wracking moment for everybody over here on this side of the room. I'd like to introduce Brad Zampt. He is the Chief Science Officer of TL Biolabs, and he's going to speak on behalf of the judges to tell us who won.
Thank you very much. And well, thank you, Rachel, and for inviting me and the organizing committee. Thank you, my fellow judges. That was a wonderful and spirited debate, but all in, you know, I think the Supreme Court, I've heard Supreme Court, yeah, I'm comparing ours to the Supreme Court, by the way, but I think the Supreme Court justices, it's very interesting to hear them interviewed. They say, you know, despite our ideological differences, it's always, everybody's always very respectful, very friendly, and it's always a good debate. So that is the same in the case of this judging panel. So thank you again to my co-judges. Everybody was really fantastic, and so that made it pretty hard. I would really like to, you all should be very, very proud of yourselves, especially, you know, they had 3 days to prepare this, is that about right? Okay, a week and a half. And you know, you identified, oh, a week and a half, yeah. Okay. Okay, they wrote them in 3 days, but they, but you know, you all identified, you know, problems that leaders in the industry and experts grapple with every day, and you all came up with solutions. That's something to be very, very proud of. So maybe we can do another round of applause for all of it. So I guess as the 80-20 rule, we spend 80% of our time talking about 20%, well, 3 of the contestants. So that was really difficult, and so I guess we can do a little. And now 3rd place. Okay, so Condor was one of the panelists' absolute favorite companies. Definitely, you've probably picked up the biggest problem, maybe and had the biggest vision, maybe the most, yeah, the biggest vision. But what prevented us from really picking you as a winner was, you know, there's no details sort of what was inside the box. And so we kind of had to guess that basically you wanted to reinvent Gen 4 reactors on a skid mount and park them next to large scale, you know, older reactors. Because again, over 95% of the fuel is left in the waste stream, and so you know, you have a lot of the work left to do. But we sort of found that if we were the government, you know, if we were a government review panel and we had a massive, massive budget, you would probably be, if it was based on that metric, that's where we would go. The runner-up would be atomic analytics. We figured that if we were venture capitalists, and that was the sole sort of metric by which we were judging people on, we would probably go with you. It's the most eminently doable idea. It's probably the fastest way to profit for us VCs if we were in that mindset. I think one of the main things was during the presentation, you know, the really big idea of being predictive was not presented, and that's rarely, you know, so. We would like to encourage you to go forth with this idea. Keep working on this, because being able to tell people that, you know, we have data and we have analytics that shows that your pump is on its way to failure was really where the real value proposition lies. And so now, drum roll please. Wait, I can't read my handwriting. New World, congratulations. You're in the sweet spot of doable but impactful. Yeah, come up. Just, I don't know. Whatever, I'm winging it, you should wing it. Yeah, just bask in your glory. So, why don't I start with why don't I start with the one thing that you should think about, which is why isn't Boeing or GE or Lockheed doing this? Okay, that was our one question. But you were in the sweet spot of doable but really, really impactful. And we think that sort of just the general idea of an assembly line manufacturing process for construction, for large-scale construction projects, especially in an industry like nuclear where almost everything is custom. The concrete on a pad is special concrete, et cetera, et cetera. So it doesn't really benefit from those economies of scale that other kind of construction projects benefit from. We thought that was really both transformative, but once again, really doable. So once again, thank you all for your presentation, and I present to you the winners of the Nuclear Innovation Bootcamp.
Finish off our presentation, so I'm going to do one and then the other. So thank you everybody for joining us today. I'm so happy that Nuclear Innovation Bootcamp happened a second time, and I cannot wait until next summer when it happens a third time. And I hope that you guys will all be here with us next summer for our third edition. I'm also really excited to see what all of these students will be doing, not just you guys with your shiny seal of approval, but also all of you guys. Because last year, it wasn't just the winning team that went on and accomplished things over the course of a year. It was all of our students. And so I'm really excited to see what all of you guys have to do. So with that, congratulations to the 6 of you. Congratulations to all 25 of you. And thank you all so much for joining us today.